Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on configuring and verifying VTP. So let's go ahead and read our objective for this lab. It says manually configuring VLANs on every switch is in a large network can be a daunting task. To address this problem, Cisco created VLAN trunking protocol or VTP. VTP is a layer 2 protocol that propagates VLAN configuration information from one switch to another throughout a network. All right, so it says, in this lab, you will learn how to configure a VTP domain name. You will also learn about VTP server mode, transparent mode, and client mode, and how each of these modes operate. All right, so it shows us our lab topology. And we can see that we have 3 switches, each connected to each other via an Ethernet link. All right. And it says switch 1, switch 2, and switch 3 are configured with trunk links between each switch, okay? So it's trunk links between each of these Ethernet links right here, all right? So let's go ahead and read our commands for this lab. First, we have configure terminal, which of course enters global configuration mode from privileged exec mode. We have enable, which enters privileged exec mode. We have exit, which exits one level in the menu structure. We have show running config, which displays the active configuration file. We have show VLAN brief, which displays parameters for all VLANs, contains the VLAN name, status, and ports assigned to it. All right. We have show VTP status, which displays the current VTP status. We have VLAN number, name, VLAN name, which curates or configures a VLAN with an optional name. We have VTP domain, domain name, which assigns the VTP domain name. And we have VTP server mode. We have VTP mode server, VTP mode transparent, or VTP mode client. And this configures the VTP mode, all right? So let's go ahead and read our lab task for this lab. We're going to keep our topology, of course, in the top left. We're going to be doing all of our configuration down here at the bottom, and we're going to be doing our readings top right, all right? So let's go ahead and read our lab task for this lab. It says in this task, or it says first, task 1, configure the VTP domain. It says in this task, you will configure the VTP domain on each switch. It says on switch 1, issue the commands to display the status of VTP on the switch. What is the VTP domain name? What is another name for the default VTP name value? All right, so let's go to switch 1 and let's give an enable and let's do a show VTP status. All right, so we can see we do not have a VTP domain name configured. So in that case, because we do not have a domain name configured, this domain name is configured as a null value, NULL. So let's see what Boson is going to say. And yes, it says the blank VTP domain name is also known as null. By default, a switch resides in the null VTP domain. All right, so perfect. It says on switch 2 and switch 2, on switch 2 and switch 3, issue the command to verify the VTP domain name is blank. So let's go to switch 2 and switch 3. First, let's start on switch 2. Let's do an enable. Let's do a show VTP status. All right, we can see the domain name here is null as well and empty. And let's do the same thing on switch 3. Let's do an enable. Let's do a show VTP status. And same thing over here. The domain name is blank or null. Perfect. Looks good. All right. It says right here, step 3. On switch 1, issue the command to configure the VTP domain name to Boson. What rule should you follow when configuring the name of a VTP domain? All right. Well, let's go to switch 1 first. Let's go configure terminal. And let's go VTP domain. And let's give the name of Boson. All right, and it says right here, it changed the VTP domain from null to Boson. So let's see what rule we should follow. It says it is important to note that once you assign a VTP domain name to a switch, the VTP domain name cannot be removed. In other words, you cannot configure the VTP domain name to a blank string or null. You can only replace the domain name with another valid domain name. So that is good information to know because I didn't know that. So you cannot change it back to null once you configure a VTP domain name on a switch. Okay, so that's good information to know. So it says on switch 1, issue the command to display the VTP status. What is the VTP domain name now? All right, well, let's do a do show VTP VTP status. And now we can see our VTP domain name is configured to be Boson. So that looks good. All right, it says on switch 1, on switch 2 and switch 3, issue the command to display the VTP status. What is the VTP domain name on each of these switches? Why? So let's go over to switch 2 and let's do a show VTP status. And as you can see, it also has the domain name Boson. And let's do the same thing over here on switch 3. And it also has the domain name of Boson. And that is because these had no domain names at first. And since it received the VTP advertisement from switch 1 changing the domain name, switch 2 and switch 3 went on ahead and updated their databases. But let's see what Boson is going to say. It says, based on the output, you can determine that switch 2 and switch 3 now have a VTP domain name of Boson. If a switch is in the null domain and receives a VTP advertisement from another switch, it will change its VTP domain name to match the domain in the VTP advertisement. And that is exactly what I just explained. Okay, so let's go ahead and move on to task number 2. It says configure the VTP mode. It says in this task, you will configure the VTP mode for each switch. All right, so number 1, it says on every switch in the topology, issue the command to display the VTP status. Based on the output, what is the VTP mode on each switch? Well, let's start out on switch 3. We already have the VTP status pulled up. On switch 3, we can see that the operating mode is in server mode. All right, let's go to switch 2. Switch 2's operating mode is in server mode. All right, and lastly, switch 1, its operating mode is also in server mode. So all of these switches within a topology are operating in server mode. All right. So let's go to number 2. It says on switch 2, issue the command to change the VTP mode to transparent mode. What are some specific characteristics of a VTP enabled switch when it is operating in transparent mode? So first, let's do the change. Let's do configure terminal. Let's go VTP mode. And you can see the different options that we have, but we're going to go with transparent and hit enter. So now with transparent mode VTP mode is a mode to where it will send updates to switches in the topology, but it will not change its own database. So say for instance, if switch 1 creates a VLAN, switch 2 will receive it, but it will not change its database to mirror switch 1. Switch 2, since it's in transparent mode, is going to keep its own database. But switch 2 will send that advertisement out to switch 3. And switch 3, if it's in client mode or server mode, it will change its database. So switch 2 now has its own database, and it will not change based on different switches within the topology. But let's read. It says when a switch is operating in VTP transparent mode, VTP is effectively disabled on the switch. Therefore, the switch does not send VTP updates. In addition, the switch does not modify its own VTP settings based on updates from other switches. And yes, that is what I just explained. All right. So it says on switch 2, issue the command to verify that the VTP mode has changed to transparent mode. All right. Let's do a do show VTP status. And yes, as you can see now, we are operating in transparent mode. All right, so that looks good. All right, it says number 4, on switch 3, issue the command necessary to change the VTP mode to client mode. What are some specific characteristics of a VTP enabled switch when it is operating in client mode? Let's go to switch 3. Let's do a configure terminal. Let's do VTP mode client. All right, and now you see it says that it has set the VTP mode to client mode. So in client mode, it can only receive updates from a server in the VTP domain. It cannot curate any VLANs or anything like that, delete any VLANs or edit any VLANs when a switch is operating in client mode. But let's see what Boson is going to say. It says right here, one unique characteristic of VTP client mode is that you cannot manually change the VTP configuration on a switch that is operating in VTP client mode. However, the VTP domain on a client mode switch can be automatically updated by switches that are operating in VTP server mode. So yes, that is what I just explained, all right? So now, lastly, number 5, it says on switch 3, issue the command to verify that the VTP mode has changed to client mode. All right, well, let's do a do show VTP status. And as you can see here, its operating mode is client mode. So that looks good. So let's go ahead and move on to task number 3. It says verify VTP mode operations. It says in this task, you will attempt to create VLANs on each switch and verify how each of the 3 VTP modes operate in relation to one another. All right. So task number 1, it says on each switch in the topology, issue the command to display the VLANs that exist on each switch. All right, well, let's start on switch 3. Let's do a do show VLAN brief. VLAN brief. All right, and we can see that we only have the default VLAN for this switch on switch 3. Let's do the same thing on switch 2. Let's do a do show VLAN brief. Brief. Oops, can't spell. Same thing over here. We have the default VLAN. And let's go to switch 1. Do the same thing. Let's do a do show VLAN brief. And we also only have the default VLAN over here as well on switch 1. All right. So now it says for step 2, it says on switch 1, issue the commands to curate VLAN 10. Switch 1 is operating in VTP server mode. What effects will your changes have on switch 2 and switch 3? Well, since it's operating in server mode, switch 1 will changes, update its database to have the VLAN 10. Switch 2 will not update its database, but switch 3 will receive the advertisement from switch 2 and in turn update its database. So switch 1 and switch 3 both should have VLAN 10 in their databases. All right, but let's go ahead and confirm that. Let's do VLAN. Let's do VLAN 10. All right, and there's no name. Just put that. Let's do exit to make sure that was added. All right. Now it says on switch 1, issue the command to verify that VLAN 10 exists. All right, let's do a do show VLAN brief. And yes, VLAN 10 does exist on switch 1 now. All right. It says on switch 2, issue the command to verify. Issue the command to display the VLANs that exist on the switch. What VLANs exist on switch 2? Was VLAN 10 created on switch 2? Why or why not? Well, I just explained that it should not have updated this database, but let's check. And yes, switch 2 still has the default VLAN only and not VLAN 10, and that is because it is operating in transparent mode. So it keeps its own VTP VTP database and does not update its database from other switches. Okay, so on number 5, it says on switch 3, issue the command to display the VLANs that exist on the switch. What VLANs exist on switch 3? Was VLAN 10 created on switch 3? Why or why not? Well, it should have been created on switch 3. And yes, as we can see, we do have VLAN 10 on switch 3, and that is because it is operating in client mode. So switch 2 sent the advertisement over to switch 3, and switch 3 was able to update its database. All right. So step number 6, it says on switch 2, issue the command to create VLAN 20. Is the command successful? What changes to the configuration of switch 1 and switch 3 might you expect to see as a result of issuing this command on switch 2? Well, the configuration or the command should be successful, and the result would be that switch 2 only has VLAN 20, and switch 3 and switch 1 will not have VLAN 20 because, as we explained, switch 2 is operating in transparent mode, and because of that, it will not. It has its own database. All right, so it does not send advertisements out. So let's do VLAN 20 over here. Let's create that. Let's do an exit. All right. So now let's move on to question number 7. It says on switch 2, issue the command to verify that to verify that VLAN 20 exists. So let's do a do show VLAN brief. And yes, we can see that VLAN 20 does exist on switch 2. All right. So let's go ahead and move on to question number 8. It says on switch 1, issue the command to display the VLANs that exist on the switch. What VLANs exist on switch 1? Was VLAN 20 created on switch 1? Why or why not? Well, switch 1 should only have the VLAN 10 VLAN and not VLAN 20. And that's because switch 2 is operating in transparent mode. But let's just confirm. And yes, we can see that we only have the VLAN 10 VLAN. And it did not get that advertisement from switch 2 because it is operating in transparent mode. So let's go ahead and move on to switch 3. It says issue the command to display the VLANs that exist on the switch. What VLANs exist on switch 3? Was VLAN 20 created on switch 3? Why or why not? Well, it will not have the update for VLAN 20. It will just have VLAN 10 again. And that is because, as we just explained, switch 2 is operating in transparent mode. So let's hit the up arrow and hit enter. And as we can see on switch 3, we only have the VLAN 10 VLAN on switch 3. All right. So now it says on switch 3, issue the command to create VLAN 30. Is the command successful? Why or why not? Well, the command should not be successful because switch 3 is operating in client mode. Let's do a VLAN 30. And as you can see, we get a message to this console. It says VTP VLAN configuration not allowed when the device is in client mode. So that just confirmed what I said. All right. So now it says create VLAN 30 on the correct switch so that VLAN 30 can propagate to switch 3. What switch did you choose? Why? Well, we should do this configuration on switch 1 if we wanted to get to switch 3, because switch 1 is going to send that advertisement to switch 2, and switch 2 is going to send that advertisement to switch 3, because switch 1 is operating in server mode. All right. Switch 2 will not update its database because it is operating in transparent mode. All right. So let's do VLAN 30 on switch 1. Let's give an exit. All right. Now it says on switch 1, verify that VLAN 30 exists. All right. So let's do a do show VLAN brief. And we can see that VLAN 30 does exist on switch 1. Let's go over to switch 3 and confirm it, because question number 13 says right here, on switch 3, verify that VLAN 30 exists. So let's do a do show VLAN brief. VLAN brief. And as we can see, VLAN 30 does exist on switch 3 now. So it looks like we're at the end of this lab. So let's go ahead and hit grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I'll see you in the next one.